Okay, here's outcome 4 notes for Science 8, Mix and Flow of Matter. So topic 7 deals with fluid pressure. Okay, so pressure is a force acting perpendicular to a surface area. Okay, and so the units for pressure is the Pascal, which is equal to 1 Newton per meter squared, or kilopascal is 1,000 pascals. So that's for like really big pressures. Here's the formula for dealing with pressure. Pressure is force divided by area. We've gone through the triangle with density, so same sort of thing. If you want a formula for pressure, you cover up P and it's F divided by A. If you want a formula for F, you cover up F and then there it is, P times A. And if you need a formula for area, it's force divided by pressure because you cover this up and you add F over P and it's there. We did some calculations with this. So calculate the pressure of 500 newtons is applied to 25 square meters. So pressure is force divided by area. So that'll be 500 divided by 25. And that's 20 newtons per meter squared or 20 pascals. And all of these are pretty much the same sort of thing. We looked at compression of gases. Pascal discovered that the pressure exerted on a fluid in a closed system, that is, at one end, could be felt unaffected at the other end of the container. We know gases are compressible because their particles can be squeezed together in a smaller volume because there's so much space between them. And then compression of the gas is possible if the gas is enclosed in a sealed container, which has to have sturdy walls for that to happen. If you do it in a balloon, the balloon just squishes out the other side, but if it's in a syringe, it would work. There's also so much space between the particles that even after particles are squeezed closer together, they're still far enough to behave like a gas. And an external or outer force is applied to the enclosed gas to push the particles together. Gases have the ability to exert a force back. They have a counterforce. So examples where we use this are like in tires and airbags, running shoes. Like tires, you hit a bump, it pushes in and then it pushes back out. And I mean, that's why we don't have solid tires, because the force of the going over a bump would be transferred right into the car. It'd be very uncomfortable. Atmospheric pressure is caused by all the air particles being pulled towards the Earth by the force of gravity. So if you're down low at sea level, the air pressure is higher, and if you're up on top of a mountain, there's less air particles above you pushing down, so the air pressure is lower. And at higher altitudes, there are fewer air particles, so the pressure is lower. That we just talked about that according to the particle theory. Examples of air pressure: your ears pop when the pressure is different on either side. So if you go up in a plane or you go up in a fast elevator, you'll feel that when you're coming back down. So basically you yawn or you chew gum, and that's a way of reducing pressure. Same thing in a juice box. When you're drinking from a juice box, right, it crushes because the pressure outside the juice box is higher than inside. But then when you take your tongue off the straw, it kind of reinflates, and that's because it's equalizing the pressure again. How do you measure air pressure? We'll use a barometer. So here is the original kind of barometer. We have a vacuum tube, and it's sitting in mercury. The air pushes down, therefore it pushes the mercury up. And then we can measure it as millimeters of mercury. Modern day barometers, though, don't use mercury because that's tough. Today, a sealed tin can could be used in place of the mercury. The air pressure causes a deflection in the lid of the can, and this deflection causes the needle to move, and we can calibrate that with pressure as well. Balance and unbalanced forces. Okay, so like the juice box I just talked about, if you're drinking from the juice box, there's less pressure inside, and that the air pressure pushes it in. Okay, if you blow bubbles into it, there'll be more pressure inside and less pressure outside. And it's kind of cool. The kids showed me it'll actually force the juice up out of the straw. If the juice box is open and you're not drinking and it's just sitting at rest, the forces will be balanced and the pressure will be balanced. And then we did that assignment. And then topic 8 talks about particles always flow from areas of high pressure to low pressure. So here's that. And then aerosol cans, right? They use CFCs, or they used to use CFCs, and that would pressurize the can. And then the pressure, when you squeeze the nozzle, helps move the whatever, usually spray paint, out of the container. Hydraulic systems is what we're looking at, the study of pressure in liquids. Hydraulic system is a device that transmits an applied force through a liquid to move something else by means of pressure. You could possibly the dentist chair, the human circulatory system, the jack or mechanical lift, all uses hydraulics, liquids to move and amplify forces. Okay, and we also use hydraulics to transport fluids, right? So natural gas, oil, water moves through pipelines. So the pipelines have to have as few bends in them as possible, but there is friction inside the pipeline. So we'll have these pumping stations to restore the pressure all the way along. And sometimes we learned earlier you can add different fluids to mix with, say, crude oil, so it'll flow better, and then you can take those fluids back out when they get to the refinery. Okay, and then there's also pneumatic system. Pneumatic system, same thing as a hydraulic system, except it uses a gas, like air, to transmit the force. Dentist precision tools, air brakes on a truck, a nail gun. Most of the equipment in shops use air pressure to run, the paint or the drill or the air ratchet. And you can have a smaller compressor as well, and it builds up pressure inside, and that becomes a deep change in pressure, producing a strong, steady force when you open up the valve for whatever device you're using. And that is the end of this outcome and the end of this video.